Welcome to the very first SMPTE Standards Webcast. Today's topic is SMPTE Timed Text. I'm your host, Joel Welch, Director of Professional Development for SMPTE. The SMPTE Standard Series is a new series of educational webcasts intended to inform people about the significant SMPTE standards development efforts and explain specific SMPTE standards. These webcasts are open to members and non-members alike, and the live webcasts are captured for on-demand playback. For this particular topic, we do plan to add captions to the on-demand playback before we make it available. Other topics include May, there is a Standards 101. In August, Metadata Vocabulary. In November, Interoperable Master Format. As I said, this is a new service, so proud to bring this to you and happy to have you participate in the very first Standards webcast. Today's guest speaker is Mike Dolan. Mike is the founder and president of Television Broadcast Technology. Mike, without further delay, I'd like to turn the floor over to you.
Thank you, Joel, and welcome to everybody. I know we seem to have a few people not only from the US but also Europe and perhaps other places. So welcome to everybody wherever you are. The presentation today is on SMPTE Timed Text, a little bit of history on it, and then we'll dive into some of the details. This particular presentation was targeted for the engineer that may be developing either encoders or decoders related to this. If you're not an engineer, then you still may find much of the material interesting, but just kind of a level set on where we were targeting this. What is SMPTE Timed Text? Well, it's an authoring and distribution format for encoding and carriage of closed captions and subtitles over the internet. It's based heavily on W3C timed text, known as TTML, and TTML is extended to support TV and caption-specific metadata and also images. This is a picture of the general caption distribution that goes along with the media distribution, both traditional and conventional distribution, as well as what is evolving on the internet today. On the left-hand side, you have some legacy formats to indicate that there's a lot of material out there today that's been archived and converted for distribution on the internet. There's also live captioning that's occurring. And in addition to the conventional television, cable, satellite, broadcast, telco now, distribution, we also have kind of over-the-top internet. And these end up on personal computers or specialized consumer electronics devices. We'll spend a few minutes on the history. We won't spend a lot of time on this, but kind of where this came from and how did SMPTE get involved. The broadband distribution of the media has increased and really become mainstream today. You can get an awful lot of material over the internet. TV program delivered over the internet uses multiple, sometimes proprietary media formats, including proprietary formats for captions. Broadly deployed TV caption formats such as CEA-608 and CEA-708, respectively, for analog and digital television, were not really designed for the internet. AOL, Google, Microsoft, WGBH in their NCAM work, and Yahoo formed an Internet Captioning Forum, ICF, in 2007 to explore options for closed captioning internet-delivered video. And there's a link there that when this is posted on the web you can make use of. It concluded that an industry standard was needed to ensure interoperability and widespread adoption. And then, as a result of the recommendation, they submitted a proposal to SMPTE. SMPTE then formed a new standards group in 2008. Members from all parts of the captioning food chain, content providers, computer IT personnel, caption service providers, broadband distributors, equipment vendors, and accessibility experts were active in the group. It established a liaison with a coalition of organizations for accessible technology known as COAT. Again, another link there you'll be able to use when you have a downloadable version of this. SMPTE took two-phase standards approach. It created a very broad core standard that embodied much of TTML, in fact all of it, and added some extensions to it. And then it published the first of several application-specific recommendations. The publications that are relevant then are the W3C TTML work available at W3C, and I have some links at the end of the presentation for where you find all these things. SMPTE published a standard 2052-1 in 2010, known as a Timed Text format, or SMPTE. Also published a recommended practice 2052-10, also in 2010, that describes the conversion from CEA-608 analog caption data into SMPTE Timed Text. And finally, of interest, perhaps, is a recent publication from the US Federal Communications Commission. There's a report and order a few weeks ago that identified SMPTE Timed Text as a safe harbor for interchange and delivery format on the internet. So just to give you a graphic, SMPTE Timed Text is really almost a thin layer on top of W3C TTML. It embodies all of TTML, and it creates a few simple extensions. So a great deal of what I'm going to talk about today is actually describing the core elements of TTML, and then evolve into a description of SMPTE Timed Text extensions. So a brief overview of the W3C TTML. It's an XML language. It's an authoring and distribution format. It's designed for broad application requirements, not just closed captions, but also subtitles and general text-based media where you have timed text displays. Another key element is it has a couple of time-based options. It has SMPTE 12M-like time that looks like hours, minutes, seconds, and frames, but it also allows offset type time like you'd find in an MPEG-2 transport stream program clock reference. Basic TTML is really fairly straightforward and easy to understand. It has a default layout, has a default region or window in the screen, and that's the root container as it's known in TTML, which is basically the full screen. It has default styles for a font, the font size, has a default grid of text on the screen, and a default color, which is application dependent, but in the case of SMPTE Timed Text is set to white. So a good deal of the presentation from here on is going to cover XML examples, and I'll walk through what some of these mean, and followed by a presentation of what that would look like in a TTML presentation engine. Bear with me just a moment here as I bring up my handy pointer. So for this gray area at the top, and I'll use this signaling here for the rest of the presentation. It's just some housekeeping XML that you either find in all documents or all TTML documents. In this case, there's some beginning preface material, and then here at the end we have some similar pieces that go along with it. And the interesting part, or at least the part I will focus on in this slide and then other ones, is the text that's highlighted in yellow. So the first thing to notice is that text is all enclosed in an element that's called P for paragraph, and it optionally has a begin and end time. The begin and end time is when the text is presented on the screen, and the end time is when the text is taken down from the screen. And this takes Unicode symbols in the text area, so it's not just English, of course. And I'll be using in many of the examples a couple of different languages here just to make it interesting. Another element that's important here is this break element, and it's used to force a carriage return line feed in old ASCII parlance. So we've set a language up here for the document default to be English, but then as we have non-English elements, they're identified, in this case, a portion of French, in this case, a portion of Spanish. Each of the P elements then creates a block of text that has certain properties. In this example, the properties are just a begin and an end time. All of these texts have the same end time, and the texts are displayed 2 seconds apart. So you see here 0, 2, 4, 6, and 8. And then all the text is taken down at the end of 10 seconds. So what's this going to look like? So that's not terribly exciting, but you get the basic idea. Each chunk of text is displayed 2 seconds apart, and for some reason it didn't come down at the end of 10 seconds, but imagine the text all came down at the end of 10 seconds. And wherever the hard break was in the individual phrases, you see it move to the next line. And the default is that it starts at the top left corner of the screen and progresses down. So that's fine if you want to take over the entire screen and put text up on it. But what if you want to control a little better where that text is and maybe have different places you want to put it? So there's some layout elements that are designed into TTML called regions. It's a container for the text. The origin is the upper left corner of the root container or the screen, and the x-axis is to the right and the y-axis is down. So what would that look like in TTML? Well, once again, we have some generic stuff up here. It's not all that interesting. The first piece of interesting text here is in the yellow highlight, and it defines 2 regions. In this case, it's fairly simple. It's defined a left-hand side of the screen, and it's defined a right-hand side of the screen, labeled left and right, respectively. And if you look at the text down below here, you see the differences are highlighted in red from the screen you saw just a moment ago, where for each piece of text, a region is selected for the text to go into. And in this case, it alternates left and right for each of the pieces of text. So what would that look like? At the end of 10 seconds, the text is taken down. And you saw that the windows, although there's not a border on these windows, the text was put left and right respectively in halves of the screen. So that's all interesting if you want to do white text on a black background, but that's often rather boring. And so there's a fair amount of styling that's defined in TTML. So to make it more interesting, you can set things like color and background color. In the case of the region, you can select where the region is, of course, and how large it is. You can also select its opacity, and a variety of alignment and overflow and padding and other properties listed here on the left-hand side. For fonts, you have some similar properties, including color and background color, but also direction. You can select various font properties, such as the family, font size, font style, font weight, etc., and some other controls for how the font and text is laid out on the display. So this is a collection of the styling that's available in TTML. Once again, the gray, boring stuff is just a preface for all this. The yellow portion here looks similar to what we had in the last one, where a region was created. But in this case, we're setting the origin and extent to be the top half of the screen, and then another region at the bottom half of the screen. And in the first case, the background is transparent, so the video comes entirely through with black text. And the one on the bottom, we have white text, and the background color is black, but it only has an opacity of 25%, which means good deal of the video is going to come through, but not entirely. And then finally, we've done a couple different things here in the body or the content portion of this. The first is that we created a container that has a common begin and end for all the text. So everything appears at time 0, and everything is taken down at time 12, and there's no begin ends on each of the P's. But the P's target the various text into either the top or the bottom window. The other thing to notice is that we've got some inline style properties. So the word brown here is set to the color brown, and the word jumps is put into italics. Now this span element here applies only to the brown and then is released and it goes back to the other color for the remainder of the text. Similarly for the italic style here, it affects the word jumps, but the rest of the text is in the properties that are either default or were set up for the region. And then finally, this div sets the color green for all the elements that it contains. So all this text here will appear in green. So what's this look like? I have a little better picture this time instead of black. Picture of the Grand Canyon for you to look at here. So in the top half of the screen we have some brown text there. We have some italics there. And of course, note the opacity in this window here where the video comes through, but there's a little bit of black. And of course the text is all green here in the lower half of the screen. So there's some elements to the styling that are a little more advanced. I showed you examples of how to do the inline styling, where you can just grab words and set the color and style and other properties of the text. TTML also provides the ability to create style sets, if you will, and that's done with the elements that are in the highlighted yellow here. In this case, it creates a style block called default with color set to white, background color set to black, font family set to monospace, line height, font size, font weight, etc. And here, when we define the region, we can now just say set the style to default. So it grabs all of the things here in the yellow highlight and uses those for the entire region. This could also be referenced from individual elements and pieces of text in here. It's not just for the whole region itself. It can be used anywhere that you can otherwise use styles. So in this case, though, it applies to the entire region, and we've defined the name of the region as pop-on, which may be familiar if you're familiar with CEA-608 captions. And then finally, the div here at the bottom selects the pop-on region for the 3 lines of text that we're going to display. Once again, it all comes on and it all goes down at the same time. There's not individual timing on the text, and we're trying to demonstrate the style. So there's not a presentation for this because it ends up looking basically the same. The next thing that TTML defined was the metadata. And the metadata has a container element called metadata. Plus it defined a variety of other elements that allow you to define a title, a description, copyright, an agent, which is a name of a person or an entity. There's a name, which is a simple name, and then an actor, which is a fictional person in the script that you may be using. It also allows any other namespace element. And this is important because we make use of this as we extended the schema to support translations from 608 and some other things. And then there's some attributes that allow you to set these when they're used on the individual text tags that are displayed. TTML also defined a number of roles. These values are all predefined. They're not defined any further other than their English meaning. But all of these are are settable for individual pieces of text. So for example, you could identify blocks of text as being dialogue, other blocks of text as being kinesec, lyrics, music, etc. Now, this metadata isn't directly displayed, but a presentation engine for the metadata could choose to do something different if it knew that it was a caption versus dialogue versus lyrics, etc. Might put them in italics, for example, or use other sort of built-in decoder properties for that particular role. So what's this look like in the XML? Once again, we have the general sort of header and trailer pieces. And in here, what we did is set the title, in this case, Fun with Pangrams. Description are 3 language pangrams used to demonstrate time text. We have a copyright notice. We also set 3 agents. In this case, it was a name, and then given an identifier of American, similarly here, French, and then finally Spanish down here. So for the 3 sentences that we've been using in these examples, you could, for each P element, paragraph of text, identify that as coming from the American, the French, and the Spanish. And these aren't languages, I just ended up using language like words, but these were identifiers that were set up here to identify a speaker. And what's important in this display is what you don't see. You don't see the metadata. So the text comes out just like it did before, default styles, using the whole screen in this case because we didn't define a region. But the metadata is there for the presentation processor to make some clever work with, as opposed to anything being natively displayed as a result of the metadata. Finally, there's one other general function of TTML, and that's the animation module. The animation module allows you to take a particular attribute, usually styling, but not always, and change its value over the course of time. So in this example, we have a paragraph of 5 seconds in duration, slightly different timing representation. There's a couple of different ways in which you can represent time in TTML. We set the color to white, and then we have a number of these set elements that say, okay, at 1 second in, for a length of 1 second, set the color to red. Similarly, 2 seconds in, for a 1 second duration, set the color to white, and so on. And then we have the actual text down here at the bottom. Now, what's that look like? So basically the text comes on, goes white, red, white, and then goes off according to the timing that was in the example. I don't know if these are too fast for everyone using the internet to get all this material, but the text is set to go on and off at those times that were in the XML. Alright, so that's an introduction to TTML, which is a very important part of SMPTE Timed Text. In fact, it's the lion's share of it, in fact. But what did SMPTE do? SMPTE did 2 things. One is it added support for images, and the other is that it added some general metadata support that's television caption specific. For the images, it defined an inline in the document representation, or you can reference images externally carried in some other transport mechanism. It supports the PNG format. The inline coding is done via base64, which is a common formatting for binary files in mail programs. And attributes are used to insert the images in a region and define the justification of the image within that region. For the metadata, there's general metadata for captioning. It allows you to define the source format for example, CEA-608. It allows some conversion attributes, and these are an indicator from the conversion from, in this example, 608 into SMPTE Timed Text, how well that was done. In other words, was it intended to be a precise representation of what a CEA-608 decoder would do, or is it sort of a best fit? One of the other things that it signals is a sliding time window of events that are all aggregated. In the case of 608, display can happen very quickly, where it may be displaying a number of characters in a row, and then there's a backspace and a character is corrected, and other things like that that are somewhat dynamic on the screen, but not necessarily, if you're doing a pure translation, you want to see an exact replication of. So there's a time window. It's kind of a strategy for doing the conversion, but there's a time window in which events are sort of smoothed out and you get the final result, as opposed to every little tiny edit that occurs on a character by character basis in CEA-608. And then it also defines a general carriage mechanism where the inline coding is done via base 64, like it is for the images themselves. And this is used primarily, doesn't have to be only for this, but it's used primarily for tunneling the original data. So in the case of a 608 use of this, it actually carries the exact original 608 byte pairs per field. So specifically what got defined is for images, there's a new element called image. Has an encoding property, the only value defined is base 64. It has an image type attribute, the only value is PNG. There were 3 attributes that were added to the div element to support images. First is background image, and this URI is either a reference to an image that was defined in the body of the document, or it's a URI to an external resource or some resource packaged with the SMPTE Timed Text document. And then there are 2 justification attributes here for horizontal justification and vertical justification of the image within the region. For the metadata, there's a new element called information, sort of a generic non-descriptive name, but and it has a number of attributes. As the origin, this is the URI of the source format if the SMPTE Timed Text was created from a translation. And we'll see examples of these when we get to the 608 details. There's a threshold value I was talking about earlier, where there's a low pass filter, if you will, for display event occurrences. And then there's a mode which indicates how exact the translation was intended to be, whether it was perfect or there's some artistic latitude done during the translation. And then there's a data element, and that allows you to encode binary data, either images or tunnel, using a base 64, and then a data type that's defined by the translation document. So for 608, there's a very specific setting for that so that you know it was a 608 translation. So what does the XML look like for SMPTE Timed Text? Once again, up here at the top, sort of the prologue information that goes into an XML document. The one addition, in addition to the W3C, TTML, and styling namespaces that were used in our previous examples, we now also have SMPTE Timed Text namespace. This metadata element here is from from TTML, but within the metadata element, we now have the SMPTE image element. We've given it a name, said it's a PNG format, and it's encoded in base 64. As I mentioned earlier, these are the only 2 choices for these 2 particular elements, but it was established that in the future other formats could be defined. Then you have a whole bunch of text that's printable using the base 64 algorithm. Lots more data here I didn't show you that would be normally, if you had a PNG file, it would take more than a few bytes to represent it. And then the end of it, end of the SMPTE image, and the enclosing metadata that was defined by W3C TTML. We have a region defined here. Not so interesting. It turns out to be in the upper right portion of the screen. But what is interesting is then in the div element, we're using this logo area that was defined here, and the SMPTE Timed Text piece of this says, okay, the background image for that logo area is this thing called SMPTE_logo16, which is what we defined up here. Now, what's that look like? One more, oh, sorry. There's actually two ways in which you can represent this, as I mentioned earlier. One is to define the image in line, as we did here in the yellow box. And the other is to simply make external reference to it in the form of a URL. In this case, it points to an image that's on the SMPTE website. Both of these will generate the exact same representation, provided the inline encoding is in fact this online resource. And regardless of which two of these XML representations you use, the end result is this. So the image was put in the upper right-hand corner of the region, and there was some text that got displayed. The SMPTE logo was some text that was in a P element there in the XML. So that's the generic part of the SMPTE Timed Text. There's a recommended practice, as I mentioned, that deals with the conversion from CEA-608. And there's some CEA-608 specific metadata that was defined, including a number of items that cover the XDS data, for those of you familiar with it. And then there's the tunneling of binary 608 data and how to encode that. There's a character code mapping into Unicode. There's some style mappings from those defined in 608 into TTML. And then there's some guidelines for how to do the conversion itself. First, let's look briefly at the caption data flow. We have some legacy and also current content in the form of a CEA-608 waveform, line 21, or we have native authoring formats such as cap files and other things that have been used in the industry. Ultimately, you end up with a stream of byte pairs of 608 data. Do the conversion process, you get a translation, and optionally, you can carry the exact data in the form of a tunnel. Put all this together into a package of some sort, which could be, for example, the interoperable master format, and that container gets moved along in the distribution system. Conversely, on the decoding, take that same container, take out the time text portion of this, and if you have a device where you need to reconstruct the analog output, so for example, if this were ending up on a device that had analog video outputs, you would want to recreate the 608 waveform. Well, because the translation isn't perfect in the sense that the TTML would be very difficult, if not impossible, to restore back to the exact same 608 data where it came from, this tunnel allows you to simply grab the 608 data out of there, put the bytes back onto the waveform, and create an NTSC output. If you don't have those outputs, then this data is just tossed during the decoding process, and then the TTML parsing and presentation is used for newer devices that don't have analog output. So what does the 608 specific pieces of this look like? Once again, we have the prologue, and in addition to SMPTE Timed Text, we also have the CEA-608 namespace, which defined a few more things. Basic mode here is preserved. That means the translator tried its best to preserve the original intent of the encoding of 608. Tells you what channel is being put into this document. In the case of 608, there are 4 caption channels. This one says it's caption channel 1, and if there were a program name in the XDS. In this case, we made up a name called demo. Then, in this particular example, a decision was made to preserve the 608 data and tunnel it. The encoding is base 64. This data type field here indicates that it's CEA-608 data, and then close of that. We defined a region like you've seen before, and then we've got a piece of actual caption data down here. So given that we didn't set up any styling, this is just a default piece of what it looks like. So all that metadata that you saw here, everything in here, of course, isn't displayed. This would be used by the decoder optionally. The language that was being done, I should have pointed out in the beginning, of course, is set here. The language of the captions in the original CEA-608. And then the text that was actually displayed was just this small string here. So where is SMPTE Timed Text used today? Well, one place is in the digital entertainment content ecosystem, known as DECE, also known as Ultraviolet. It has a constrained profile for doing subtitles and captions in their long-form media file format, known as CFF-TT. It's also currently in the draft SMPTE Interoperable Master format, IMF. It's work that's being done in Committee 35 PM. For those of you not familiar with that, it's a standard for the interchange from distribution in a studio to other points in the video audio distribution network. This would be an output of the studios. SMPTE Timed Text is also being used today, although it's not widely known, in some vendor-specific media distribution silos. By that I mean a single vendor controls both the encoder and the decoder, and happens to be using SMPTE Timed Text to deliver captions, but it's not a interchange point, so it's typically not published that they're in fact using it. And what's next at SMPTE? Well, we're currently working on a translation of CEA-608 2052-11. We're working on a translation of the digital cinema subtitles and captions. That's SMPTE standard 428-7. And this particular one, the translation is actually bidirectional. We're updating the XML schemas based on some recent W3C TTML updates. W3C, within the last week or two, published some updates to their schemas that more accurately reflect the prose in the TTML standard, and therefore makes it easier to derive particularly metadata, but also adding attributes to div, for example. And so we made some updates to the schemas based on that. And we also have a schema for 608 and forthcoming 708. We're also re-exploring the use and practices in the industry. So the standards have been out there about a year. What are people doing? Which portions of it are they actually using? Should we look at doing a constrained profile? Do we need to extend it? Are there functions that are needed that are currently not in there? And as I mentioned, the documents have an actual formal process to do a one-year review after publication of all new standards in SMPTE, which would have an opportunity to update 2052-1 and 2052-10. Here's some additional free reading. You've got the W3C TTML spec. You've got SMPTE 2052-0, which is an overview document that staff prepares when you have multi-part documents. Gives you a little bit of a roadmap for what the other ones do and say. And of course you've got 2052-1, which is the broad extension with images and metadata. 2052-10 that now has an amendment on it. There were some typos in the Unicode translation tables. Found a couple of errors in there, and that was fixed about a month ago. So those two documents. And then I mentioned the very beginning of the webcast about the FCC report and order. And all these documents are available from free in the various places. My contact information is my email address. Also like to specifically acknowledge input from Craig Kuttner at HBO, who chairs the 24TB Captions Ad Hoc that's doing the heavy lifting on all this work, and Anne-Marie Rahali at Microsoft, who's my co-chair of 24TB. So what I'd like to do is open the floor for questions, and I'll hand it back over to Joel to moderate, and thank you for all your attention so far.
Thank you, Mike. Very, very interesting. And we do have a number of questions in the queue. The first of which is, if you would review, how is SMPTE Timed Text related to ISO MPEG-4 Part 17, ISO Timed Text?
So I'm not familiar with Part 17. This the 3GPP work, or is this something else? Wonder if the commenter could clarify.
And he says 3GPP.
So this is different. First of all, it's based on W3C TTML, and also it has the addition of, in the case of SMPTE, time text, images, and metadata suitable for helping convert from existing captioning formats. So at a very high level, those are sort of the basic differences, but they are different.
A question came in privately. Does the region's opacity apply equally to background and font/text?
Yes, you can set opacity on the text, although it's not with the opacity attribute. The text color, in addition to using the words white, green, blue, etc., you can set an RGB alpha value, and by doing that you can also have opacity or alpha blend, if you will, on anything that a color can apply to, including the text, of course.
Could you tell us who, how, and for what purpose has the W3C TTML started?
Oh boy, that's going back. The group was formed in, I want to say 2002 maybe, or 2001, something like that. And this group was set up by W3C to define a time text standard for a variety of purposes, one of which was potential use for captioning and subtitling on the internet, but it was much broader. It was a way in which to do time text as part of a multimedia presentation. So it was intended to be an adjunct to timed video and audio that was still in its nascent stages of development in W3C. This was going to allow the ability to put up text that was time synchronized to video and audio elements. As part of that development, consideration of functions and features of CEA-608 and 708 were put into the pot. It isn't a complete mapping. There isn't, if you start with 708 or 608, it's not possible to do a perfect representation, but it's very close, particularly for all the commonly used components of it. Similarly, there were other requirements that were put in that resulted in the end with the TTML that was published a little over a year ago.
And our next question. Will SMPTE define carriage of SMPTE Timed Text in the MP4 file format and RTP streams?
At this time, we don't have a work item to do the MP4 or RTP carriage. That's not to say that we wouldn't. However, I understand that MPEG is looking at the MP4 carriage, and I don't know the status of that or how public it is, but there's at least a activity in MPEG to do MP4. I'm not aware of anyone doing a RTP transport carriage. Not to say there isn't someone doing it, but I'm not aware of it.
Next question. SMPTE Timed Text seems to allow tunneling of CEA 608/708 captions. Does it similarly allow tunneling of WST teletext?
Today there's no mapping. Well, strictly answering your question, does it allow it? Yes. But there's currently no defined mapping for WST into SMPTE Timed Text. There's actually an activity in the EBU. It's defining EBU Timed Text that is looking at some of those issues. It's similar to SMPTE Timed Text in that it's based on TTML and it extends the metadata, etc. But it doesn't make use of the SMPTE Timed Text extensions. And as far as I know, there's not somebody looking at a translation directly into SMPTE Timed Text. But EBU would be a good resource for learning more about what's going on with WST.
And our final question in the queue so far. Does SMPTE Timed Text allow mixing of tunneled 608 captions plus actual text, parentheses non-608 data, at different timeline positions on the content?
So the current standard, if I understand the question correctly, the current standard was set up initially thinking that all the tunnel text data or all the tunnel data would be put in the headed portion of the document. In other words, you'd gather up all the 608 data for the entire document and put that into the head. As I mentioned in the one-year review, one of the things that we learned during real implementations of all this is that's fine if you have a computer and lots of time to fool around with a document. But if you're trying to push the document through a stream or parse it in pieces, then that becomes a nuisance because now you have all this metadata that's the 608 tunnel that you have to wade through before you ever get to the very first piece of SMPTE Timed text. And so as a result of that experience, we're looking at allowing for the tunnel data to be interspersed and coincident with the actual translated text that's put into the document. So as part of the review process here in the near future, we'll be revising -1 very likely to allow for the metadata to be more generally distributed in the document. And in fact, the 708 tunnel design in the draft currently makes use of that anticipated feature. In other words, the 708 data is interspersed throughout the document and not jammed into the header.
And Mike, that appears to be the final question in the queue. So with that, I would like to thank you for putting in the time and energy to create this very informative presentation.
Well, thanks, Joel, and thanks everybody who showed up and listened, and thanks for the questions. They were all good, and anyway.
And I'd also like to thank our guests for joining us because everybody is busy, especially in these times. As a reminder, this is a new service of SMPTE. It's an educational service covering SMPTE standards. And our next quarterly session will be Standards 101 in May. So with that, thank you. Thank you, Michael. Take care, and we look forward to seeing you next time.